Good day everyone, welcome back to our new video for today. My name is I am Justin P. Cabarles and welcome to our I Am Build channel. And today we're going to discuss about the sequence. We're going to discuss about different kinds of sequence and the, the definition of sequence. So now, what is sequence? Sequence is a set of things, usually numbers, that are in order. So, in short, sequence is just a series of numbers, especially numbers. For example, let's have here 1, 2, 3, 4, 5, and so on. So, this is a sequence of numbers 1, 2, 3, 4, 5, so on and so forth until infinity. So, that's an example of sequence. Now, there are so many kinds of sequence, but I have here for you, I will discuss some of this sequence, the arithmetic sequence, geometric sequence, and the Fibonacci sequence. I will discuss about a little bit of those things, how it works, how they differ from each other. So, first we're gonna discuss about the arithmetic sequence. So let's go. Now we have here the arithmetic sequence. So now what is arithmetic sequence? Arithmetic sequence, the difference between one term and the next is a constant. In other words, we just add the same value each time, infinitely. So basically, or in short, arithmetic sequence is a sequence of numbers that has a common difference. So it has the common difference with its consecutive numbers of terms. So we have here a formula to find the next term of an arithmetic sequence. So the formula is a sub n is equal to a sub 1 plus n minus 1 times d. So we have here a sub n is the number of term. Then a sub 1 is first term, the first term. For example, we have an arithmetic sequence of 1, 3, 5, 7, and so on and so forth. So the first term is the a sub 1. Then d is their common difference. The difference of the two consecutive numbers, anywhere of these. Now, we'll try to solve an arithmetic sequence or a problem. So let's erase this one. For example, find the 40th term of the sequence. Of the sequence, find the 40th part of this sequence. For example, we have 1, 3, 5, 7. So we have here, we are given of 1, 3, 5, 7. So now we're gonna find the 40th term. Now our a sub 1 is 1. Our a sub n, or the n, is 40 because we need to find the 40th term. And our common difference is, for example, 1 minus 3, so our common difference is 2. Now we can solve this using this formula. A sub n is equal to a sub 1, which is 1, plus a sub n, which is the 40, minus 1, and then times it with the difference, common difference, 2. So we have here 1 plus 39, which is 40 minus 1 times 2. And then 39 times 2 is 78. So 1 plus 78. And then, sorry, 1 plus 78. So we have 79. So the 40th term is 79. Let's have another example. For example, we need to find the sixth term. So we have 6 here, and then 1. So a sub n is equal to a sub 1 is 1 plus 6 minus 1 times the common difference 2. So 1 plus 5 times 2, and then 1 plus 10, 11. So the sixth term is 11. So let's check. 1, 3, 5, 7 plus 2, 9 plus 2, 11. So 1, 2, 3, 4, 5, 6. The sixth term is 11. So we have the right answer. So that's all for arithmetic sequence. And then we can now proceed in the geometric sequence. So now we're going to discuss about the geometric sequence. What is geometric sequence?
Geometric sequence. Each term is found by multiplying the previous term by a constant.
So in short, geometric sequence is a sequence of numbers which has the common ratio of the consecutive numbers. For example, we have 5, 15, and 45. So through this, we can verify that it is a geometric sequence, because 15 divided by 5 is 3, and then 45 divided by 15 is 3. So the common ratio is 3. Now, a sub 1 is 5, then our n is 12, then our a sub n, the ratio is 3. Now we can solve this through the formula. So a sub n is equal to the first term 5 times the ratio 3 raised to the power of n, which is 12, minus 1. Now we have 5 times 3 to the power of 11, 12 minus 1. And then we have 5 times 147, 147. 3 to the power of 11 is, the result is this one. And then times it, we will go 885,735. So based on this sequence, we can say that its 12th term is 885,735. So we're done discussing about the geometric sequence. Now we're going to jump to the last one, which is the Fibonacci sequence. Now we're going to discuss about the Fibonacci sequence. What is Fibonacci sequence?
Fibonacci sequence is the series of numbers 0, 1, 1, 2, 3, 4, 5, 8, and so on and so forth. The next number is found by adding up the two numbers before it.
So we have now this Fibonacci sequence, and then we have here, this is a Fibonacci sequence 0, 1, 1, 2, 3, 5, 8, 13, 21, so on and so forth. Now we can derive that the Fibonacci sequence is the sum of the two consecutive numbers. For example, 0 plus 1 is 1. By the way, Fibonacci sequence always start with 0 and 1. So 1 plus 1 is 2. Then 2 plus 2 is 3. Then 3 plus 5 is 8. And then 5 plus 8 is 13. So on and so forth. So we have here the formula, which is a sub n minus 2 plus a sub n minus 1. Now we can we can we can now predict the next term, possible next term of the Fibonacci sequence. By the way, Fibonacci sequence finding its nth term is a quite broad topic, so we're just discussing about the basic part. For example, we have a sub n, sorry, a sub n, a sub n. For example, we have the 13, so 13 minus 2 plus a sub 13 minus 1. 13 minus 2 is 11 plus 13 minus 1 is 12. So the 13th term of the Fibonacci sequence is just 24. I mean 23. 11 plus 12 is 23. So guys, that's all for today. Thank you for watching, and I hope you learned something for today. Please don't forget to like and subscribe to our YouTube channel. Thank you guys for listening. Have a good day.